Let me do this question, which I made myself, with 4 methods. It's a good example, good question to practice the basic techniques of those complex numbers. Okay, now we can use the formula that is 1 over 2i and e to the I 2i minus e to the negative I 2i. Yeah. So this one is equal to square root 2i, and this is e to the negative 2 minus e to the positive 2. Okay, then if I multiply by I both top and the bottom, and it becomes 2, and then numerator becomes negative I. I switch the order, it becomes negative 2, right? Then square I. Yeah, that's better. Okay, so this one is equal to square root e squared minus e to the negative 2 over 2 times I square root. I is e to the I half pi square root. So this one equal to square root e squared minus e to the negative 2 over 2. This is a quarter pi, right? This is equal to cosine quarter pi plus I sine quarter pi. So this is 1 over root 2. This is 1 over root 2. So 1 over 2 taking out becomes 2 here. Square root e squared minus e to the negative 2 and 1 plus I, right? Wow. This is my answer to this one. Now, if you want approximation, this is approximately equal to 1 over 3,466 times 1 plus I. That is an approximation. Okay, this is the first method. Second method, this is method 1. Method 2, I let this sine 2i be a complex number, a plus bi. Therefore, both squaring both sides. So sine 2i is equal to a squared minus b squared, right, plus 2abi. Yeah. Then I'm using the formula of 2i e to the I 2i minus negative I 2i, right, is equal to a squared minus b squared plus 2abi. Then I multiply I both sides. So this one equal to 2e negative 2 minus e to the square is equal to a square minus b square I minus 2ab. Okay, this side is a real number. That side is a complex number. Therefore, the real part must be 0. Okay. The real side, no I. I'm sorry. When you multiply by I, becomes -1. See, okay. So therefore, this must be 0. A squared by must be equal to 0. So therefore, A squared equal to B squared, which means that A equal to plus or minus B, right? Now, this is negative. I change this one to positive. Therefore, 2AB must be equal to this number, negative. So I switch them. I switch, yeah, I switch them and change it negative, right? Now, this number is positive. Therefore, AB must be same sign. Either AB both positive or AB both negative. So A cannot be negative B. So that means A equal to B. Yeah, yeah, that's right. So A must be equal to B. If A equal to B, this means that uh, well, this means 2A squared, right? 2A squared is equal to this. So A is equal to what? A is equal to 2 on this, see? E minus E negative 2. So I find A, right? Yeah. Therefore, therefore, square root sine 2I is equal to A times AI. A is this. So AB is the same, right? All right. I find that the result same as method 1. Okay, method 3. Method 3 is this. E to the I to I by Euler's formula, this is equal to cosine 2I times plus AI sine 2I, right? Yeah. So this means this is e to the negative 2 is equal to plus or minus square root 1 minus sine square over 2I, right? That is cosine plus I sine 2I. Then this means plus or minus the square root 1 minus sine squared 2I is equal to e to the negative 2 minus I sine 2I. Then I square in both sides. So this is, the left-hand side becomes 1 minus sine square 2I. This side is square is equal to e fourth, negative 4, right? This is square is becomes I square is a negative 1, right? So sine square 2I and minus 2e negative 2 sine 2I. So this cancels with that. So I can find the sine 2I is equal to e to the negative 4 minus 1 divided by, I'm missing I there, 2 times this term, this, right? 2 EI times divided by 2e negative 2. There's I here. Okay. Then I times e square, both top and the bottom, right? And times e square, right? Times e squared times I, both top and the bottom, by this. So this becomes 2, right? This times in denominator becomes this. And the numerator changes sign, it becomes e square minus e to the negative 2I. Yeah, it's good. I multiply this one to both numerator and denominator. I get this. So 2I is equal to e to the square minus e over 2. This is e to the I half pi, right? Yeah. Then I take the square root, sine 2I. This becomes e square minus e negative 2 over 2. This becomes e to the I quarter pi. So then it's same thing. This one is equal to e square minus e to the negative 2. This is 1 over root 2 plus I 1 over root 2. So finally, I get the same thing. Square root of 2I is equal to, I write too fast, so e to the square minus e to the negative 2 over 2, 1 plus I. Yeah. Okay, same answer by method 3. Now, method 4. Method 4. I let the sine 2I be r times e to the I theta. R is modulus, theta is argument, right? This one is, well, the left-hand side is this, 2I and e to the I 2I minus e to the negative I 2I. the right hand side is equal to r times cosine theta plus I sine theta. Yeah. Okay. Now this is equal to, if I multiply I both top and the bottom, it becomes 2 I, right? Change the sign, becomes e to the square minus e to the negative 2. Yeah. This is equal to r times cosine theta plus I r sine theta. Now this is a real number, not 0. Therefore, this must be 0 because the real part is 0 here. This complex number, the real part must be 0 too. So this means that cosine theta must be 0 because this cannot be 0. R cannot be 0. If I was 0, the number is 0. Now, it means that theta is equal to half pi, right? Which means sine 2I is equal to r times e to the I half pi. Well, this means equal to what? This is r times sine half pi, right? I. Yeah. Okay, which means equal to I because sine pi is a 1. Now, then we have this, right? This is equal to, this side is, it's already switched to minus 2. Okay. I is equal to IR. So R equal to, yeah, I equal to R. No R. Yeah. Good. Then we square both sides, therefore this one sine 2I is equal to square this. Minus e to sine, okay. Yeah. I take a square root. This is R, this also I times, I have to square both sides. So square root of this one means square root of that. Square root square R is this. Square root e to the I theta is this. So this means this is equal to half e squared minus e to the negative 2 times this. This is e to the I quarter pi. So this is the same thing. Same thing as 1 over root 2 plus I 1 over root 2. Huh? So finally, we get the answer 2I is equal to square root e to 1 is e to negative 2 over 2, and the 1 plus I. Yeah, we get the same answer. Thank you.